Okay, let's go ahead and get started. Learn about TypeScript. Everybody ready? Yeah. Chris, keep it down. So just to introduce myself, my name is Quinn Heiner. I am a full stack .NET developer. I've been with STG for over 5 years now. And just as kind of an icebreaker, one of the most important certifications that you could have is the WOM certification, if you're not familiar with it. The Works on My Machine certification program. So all you have to do is, to earn the certification, you compile your application code. Getting the latest version of any recent code changes from other developers is purely optional, not a requirement for this certification. Launch the application or website that has just been completed. And step 3 here, cause one code path in the code you're checking in to be executed. The preferred way to do this is with ad hoc manual testing of the simplest possible case for the feature in question. Omit this step if the code change was less than 5 lines, or if, in the developer's professional opinion, the code change could not possibly result in error. And then check the code changes in your version control system. Piece of cake, right? How many already have that certification, by the way? All right, sweet. Okay, so get out of this thing. You don't know how to exit F11 here? Okay, here we go. What is TypeScript? So TypeScript is not a JavaScript library. That's what I want to make clear. You've learned nothing in this presentation. Know that it's not just a JavaScript library like Angular and jQuery. TypeScript is a type superset of JavaScript. So in other words, we're extending the syntax, and we're going to have a compilation phase where the TypeScript will be compiled into JavaScript. And so this gives us a ton of advantages. We'll talk about them more later, but basically another thing to remember is that TypeScript is open source, developed by Microsoft, started by Microsoft. You can download it as a Node.js package. You also are able to, a lot of the built-in like Visual Studios and some of these other text editors, Sublime, WebStorm, these types of things have built-in support for it. But at the very least, you can compile everything from your TypeScript to your JavaScript from the command line. So TSC is the TypeScript compiler engine that will do the conversion for you. So TypeScript is also cross-platform. So you can target different versions if you want. You can target ECMAScript 3, which I believe is the default. You can go all the way up to whatever, even ECMAScript 6 or ECMAScript 2015. So there are some experimental features like async functions, decorators. We're not going to get into a lot of those that can target upper versions of that. So basically, in addition to your client-side stuff like browsers and things like that, running JavaScript, you can also, for your server-side JavaScript, such as Node, also is compatible with TypeScript. So in terms of advantages of TypeScript, we have advanced language constructs now available. Again, we're extending the syntax. So all these object-oriented principles that you're used to learning, interfaces, types, inheritance, generics, polymorphism, we're going to talk about all of these today. And basically, those constructs are available in TypeScript now, and it will compile to your JavaScript. We have static code checking. So TypeScript is compiled, so you have static code checks on your code. Static code checks and refactoring support. And so we're actually going to see that in Visual Studio, for example, our application won't compile as a result of a TypeScript error. So you essentially have that static code checking of JavaScript available to you. And then, of course, it's very scalable. Because we have a more disciplined approach to our JavaScript and we're writing it in a very object-oriented way, very declarative way, the code becomes very much more maintainable and fewer bugs. So today's agenda, first we're going to look at some of the dirtier aspects of JavaScript and see how TypeScript can fix them. And then we're going to go over some of the basic language features and then some more advanced language features. So how weird is JavaScript? We got a string minus a number, right? Not bad. So that's going to give you some sort of error, right? Nope. Due to weak typing, implicit conversions, all that dirty stuff that JavaScript does, it'll just go ahead and do the math, even though you have a string and a number, right? Okay, for sake of consistency, though, this is going to do what? 8, right? No. It concats them. So it thinks plus is kind of overloaded, right? We just have 2 strings. Can we do math on strings in JavaScript? Okay. This is where it starts to get weird. Right? What about foo plus plus foo? Just concatenating 2 strings, right? Piece of cake. Should be foo foo, right? No. 5 plus minus 2. Now, if you don't believe me on this one, I'm going to actually copy this one because a lot of people. I kid you not. Okay. What about, we're doing triple equals, right? Do you guys remember the difference between double equals and triple equals? One's going to type coarse, one's not. So this has got to be true, right? Wrong. What about a new array? This will return a Boolean. What do you think it's going to return? It's a new array false or true? What's it going to give you? Isn't that weird? What about type of null? Null this should bomb out or something, right? No, it's an object. But is null an instance of object? No. What about 2 arrays? Duh, that should be equal, right? No. What about 2 objects that are basically the same thing, right? No. But what if we concat it to an empty array? And we're going to do triple equals just to make sure it actually returns true. What do you guys think? 42 is the answer. The answer is 42. So in other words, JavaScript is dirty, and it's because there is no type checking. Strings, arrays, integers, types, whatever. It just doesn't care. And to JavaScript's defense, it was developed in like 2 weeks, right? And at the time, I don't think they imagined it being as ubiquitous and as popular as it is today. So we're going to give it some discipline with TypeScript. So let's talk about the top 10 basic features here. So transpiling. All that's happening, you can technically think of it as, it's not technically compiling. We're going to use the term compile loosely. It's basically transpiling, right? Because we're going from a TypeScript, which I guess you could call it compile, but we are actually just outputting JavaScript. So we're outputting the scripted language. So it's technically transpiling. But all that happens basically is we're going to take some of these keywords and we're going to convert it. And if you notice, kind of the pattern here is this concept of iffy, immediately invoked function execution expression. And so what that means is we surround this guy with a parens and we call itself, and that basically gives us access to this as what we would call in object-oriented programming, a class. So let's talk about source mapping. Source mapping is absolutely critical to be able to debug TypeScript. Basically what we do with source mapping is we are able, even though the client, at the end of the day, remember the client's only going to see JavaScript. But here, we're able to actually see the TypeScript files in our browser. And what it does is it will map every line of TypeScript to the actual JavaScript that the client sees. So when you're debugging, you're going to be able to see, you're going to be able to step through your TypeScript code, even though the client is reading it as JavaScript. And the only thing you have to do is enable JavaScript source maps. And every browser, every modern browser that's up to date that I know of supports source mapping. So again, debugging is easy. Let's talk about variables. Now we're going to get to the point where these code examples, I highly recommend if you end up going through them, if you end up following along later, that we go ahead and paste them into the actual website. Is this TypeScript playground. It's from Microsoft's official website. And this is where we can kind of see what's happening behind the scenes. So variables are pretty straightforward. On the left, we have our TypeScript, and on the right, we have our JavaScript that's generated. And you see, a lot of this stuff at the end of the day gets lost when it gets converted to JavaScript, but that's okay, because at the end of the day, it doesn't matter, right? But we want to enforce everything in the compilation part. We want to enforce everything at the time the code is written, not at the time that it's actually executed in the browser. So what we have here is we can declare any variable we want, and by default, you can hover over this. Again, this is very similar in Visual Studio. You're going to get red squigglies, you're going to get IntelliSense, you're going to get all those great things that you get on your C# languages and stuff like that, your .NET languages. You're going to get that with TypeScript as well. So if you hover over this, you notice that it's of type any. That's kind of the default JavaScript. You know, we don't know what it's going to be at this point. You can, TypeScript will implicitly figure out what it is if you initialize it to a value. So for example here, even though I haven't actually declared it yet as type number, you'll see it's still a number. And then you can always do colon and then the data type. And then that's another way to declare it. So does anyone know the difference between var and let? This is a new ECMAScript thing. TypeScript supports it out of the box, but this is very helpful for scope because JavaScript scope, as you know, is much different than your standard object-oriented scope that's usually just braces, right? As soon as the variable's outside of that brace, it's lost scope, right, in your compiled languages. Well, in JavaScript, that's not the case because I can alert, notice that I'm outside here, I can alert this variable and it's still in scope. Does anyone want to venture a guess as to why? It's hoisted, yes, perfect. And what about this guy? Now we have this let syntax that will not do the hoisting. So now we would get actually get an error here. But look at what's compiled. Doesn't care. Var, let, at the end of the day, it's the same thing, right? But I'm pretty sure the latest version of ECMAScript, you are going to actually be able to use let natively. But in terms of browser support, I don't know. So it's easier to just do everything in TypeScript because like jQuery, that's going to standardize the JavaScript across the browser implementations. All right. Data types. So basically built-in data types, we have Boolean, string, number, and any. So doesn't that kind of defeat the purpose of TypeScript if we have an any data type? When would we want to use any? Sometimes we really do want that to be dynamic and determined later on, whatever. But one of the main reasons I found is if we're working with a third-party library and it's not really enforcing anything, it's a good thing for backward compatibility. User-defined types, we're going to talk about enums and arrays, which you technically have to specify, interfaces and classes. We'll talk about all these. So this is pretty standard stuff in terms of data types. I don't want to spend a lot of time on this, but basically we can do Booleans, we can do strings, we can do numbers, and as we know, JavaScript numbers are anything, decimal, int, float, whatever you want to call it. This is a very different implementation than your numerical representations in your compiled languages. And then, of course, you can do any as well. Now, arrays, you just literally do the bracket notation, or we can use what we call generics, which we do have support for in TypeScript. We'll talk about that later. Here, we can just do the angle brackets here to denote that this is an array of type string. In terms of tuples, we actually do have support for tuples. Basically, you can specify a mixed type array, and that will work, okay? In terms of enums, we'll talk about these more later, But enums are pretty straightforward in TypeScript. You have the numerical representation or the string representation. And you can, of course, enums at the end of the day are just numbers, right? You can assign the numbers as well. Otherwise, it will just be in sequence. Okay. In terms of enums on JavaScript, when it compiles to, it's very tricky. It basically does a fancy object. It has these indexers and everything else in order to build that. But just to think that we would have to do something like this to get an enum in JavaScript speaks to some of the simplicity and just how much easier it is to do this kind of stuff in TypeScript. And if you guys have any questions along the way, just let me know. Okay, classes and constructors. Yeah, go ahead. I try to be consistent, and I'll try to always declare the type wherever I can, but it is pretty implicit. TypeScript will figure it out if you initialize it right at the time you declare it. Yeah, there's really no standard per se, just your personal preference. In terms of classes and constructors, okay, so constructors, very straightforward, except for a couple of things to note. If you can only have one constructor per class, but you can have optional parameters, and we'll talk a little bit more about these. But basically, for example, the language here, if you have the question mark at the end of it, that does make it optional, so you can pass whatever you want. You don't have to pass a value for that. So that's kind of a way you can do overloaded constructors if you want in TypeScript. In terms of this message property, for example, if I were to make this public, we'll talk about access modifiers in a second, but basically you'll notice that that implicitly creates a class level variable that you can access, similar to if you do it here in the constructor. Okay, in terms of class members, talking about properties and methods. All right. We actually do have getters and setters in TypeScript that we can do. It's a little bit trickier. The getter logic must return a value and the setter logic must return void. But basically you just have the name of the property, and if you have the empty function, a function without any params, then that will essentially make it a getter. And then you just get it or set it with the dot syntax as you're used to doing. So the only time you'd really want to use this as opposed to just having a property on the class is if you want some additional logic to calculate when you go to get the function or when you go to set it. You want some additional logic in there, you can do that. But in order to achieve this in raw JavaScript, you've got to do a lot of stuff. So it's really something to be grateful for that TypeScript does all of this out of the box for you. Because, JavaScript is all about prototypes. It's not a classical inheritance type of language. And so you really have to do some things that kind of are difficult to comprehend when you just see it there on the screen. Encapsulation. We kind of already touched on this a little bit. But we basically have three options: public, private, and protected. So we do have inheritance and all that good stuff, and that obviously is where our protected comes in. But in terms of others, we have public and private, and that does exactly what you think. The private stuff will only be accessible within the class. In terms of public, this is what's different from most compiled languages. It is the default. So if you don't have any access modifier in front of it, it will assume that it's public. And so you'll notice here, I have my logger, I have my client message as public, so that's going to create, again, that creates that implicit property. And then we have this private one here. You'll notice I get a compiler error because I've declared that outside the class and it's labeled public. Same is in terms of the log message as well. This also is not accessible. Sorry, I keep forgetting to show you guys the JavaScript alongside of it, but essentially, the JavaScript doesn't care. Because again, we're only doing the enforcement on the TypeScript side. You could achieve private variables. You could make it private if you really wanted to tweak the JavaScript. But if you're doing everything in TypeScript, it doesn't matter. Yeah, go ahead. Yes, we will talk about that. Yeah, that's coming up. Okay, function features. So a lot of these new function features, it's interesting how you see the way TypeScript is natively supporting it, and ECMAScript 2015 or ECMAScript 6, whatever you want to call it, they're starting to support some of these things natively. But again, browser implementation vary, so it's good to stick with the TypeScript so you can standardize it and have a little bit cleaner syntax. So in terms of, we have arrow syntax, default params, variable params. We touched on these a little bit, but we'll touch on them more in a second. We have required and optional params as well. In JavaScript, everything is optional. And this is where we really get the power of TypeScript checking things, because you call functions, and if you don't have the right number of arguments or it's out of order or whatever, it gets really messy and it is error prone. So we do have that enforcement here in TypeScript that we can rely on. Okay, so if you guys are familiar with Lambda expressions in your compiled languages, functions as higher class citizens, function pointers, anonymous functions, all of this kind of ties into the concept of syntactic sugar and being able to have anonymous functions. So in terms of standard syntax, we can just declare a variable and have it be a function, right? And just to kind of illustrate the different options you have with your params and your functions, you can actually set a default value if none's provided. You can make it optional like I talked about earlier with the question mark. And then you have this, what we call a rest param, that basically with the ... in front of it enables you to have a variable number of arguments. It's not like you're passing an array, even though you're declaring it as an array. You're actually able to just, similar to your compiled languages, you can just list whatever. So obviously it has to be last in the list, right? And then your optional params have to be after the required. Let's try it. Yeah, you're going to get an error if you do that. Yeah, it enforces that. And again, all these errors you're seeing, some of your IDEs, especially Visual Studio, it's going to show you this stuff, and it won't let you compile, it won't let you build. I think you can only, yes, the type would have to match. If that's what you're getting. I don't think you could. Yeah, so you're saying if I did something like this, optional number 2. I don't think you can do that, can you? Oh, guess you can. I think it will probably just do the first one. Yeah, it is fickly. So you just want to make sure your signatures are pretty clear. Yeah, good question though. Okay, in terms of syntactic sugar, this is where we get into the syntax that's a little kind of weird at first, but once you get used to it, it's actually quite intuitive. You basically have an arrow function. This guy here basically replaces the need to have the function keyword. If you have more than one parameter, you surround it in parens, and everything inside the parens becomes your input parameters, I guess you could call it, and then the function body just goes right after the braces. So again, you can kind of shorten things up a little bit with that syntax. Yes, yes, it is. That's a good point. Okay, this is where it gets kind of fun, and this is where JavaScript, if you really understand functions, JavaScript can be very powerful and even do some things that compiled languages generally don't do out of the box. We're not going to go into some of the advanced stuff, but we can actually pass functions as types. We can declare functions as true types. So basically what that means is I have a function here, for example, increment function, and I've declared it here. And then I have this increment function type doing that lambda syntax that we just talked about, declared it there, I can set that equal to the function, and I can call it. So kind of like a whole delegate pointer situation. This has a lot of potential if you use it right. Okay, so enough about functions. Let's talk about enums, whatever you want to call them. Basically, we already kind of talked about this, but I just wanted to show you just the level of what you have to do. So many more lines of code. All of these compiled examples, you'll notice there's so many more lines of code in the JavaScript in order to get it to work. You do it in 1, 2, 3 lines in TypeScript. Again, like we talked about, you can just have the string representation, or sorry, the numerical representation if you access it directly, or if you have the indexer, you get the string representation. And basically, at the end of the day, it's just an object. But we are now limiting, obviously, what values can be in enum. Okay, interfaces. Interfaces are probably one of the best features, in my opinion, of TypeScript because it's so simple. You don't have to do all this prototype stuff. Basically, you just declare an interface. It's very declarative, very expressive, and clear, concise what you're doing. Again, you can have optional parameters in interfaces. You have functions, again, state and behavior, right? But all the implementation details obviously are in the classes that are implementing those interfaces. So we have this dog. Notice that the dog does not have that type property. And cat also implements animal. Again, we have these different speak methods, the whole concept of polymorphism, which we'll talk about in a second. I can run this and say, okay, I have these new instances. Let's have the dog speak hello and the cat speak hello. You'll notice, rough, rough. Yeah. So, very powerful. And again, all that prototype stuff, don't even have to worry about it. It abstracts a lot of the JavaScript that you have to do to achieve the same effect. So that's kind of the basics. Any questions so far before we go into some more advanced features? So multiple inheritance, we'll talk about that in a minute. You cannot do that in JavaScript, but you can extend, you can have the hierarchy, obviously. You can extend an extent of an extension, right? In terms of interfaces, I'm pretty sure you can do multiple. Yeah. Okay, type definitions. So type definitions are basically you have a .d.ts file extension, and all of these files really are for your third-party libraries. So if I want IntelliSense in Visual Studio, I want type checking, I want to be able to make sure that I'm calling the right method with the right parameters. All of that static code checking that we want for our third-party libraries, pretty confident that if it's a well-known third-party library, you're going to be able to find a type definition file for it. And all it is a bunch of interfaces that you code against, basically. So if you go to this website, this definitely typed, I think there are about 1,500 libraries that people have actually gone through, and you can contribute to this if you want. It's GitHub, right? It's a public repo, and basically you can contribute all of your interfaces for your own stuff if you have third-party libraries out there. You notice we have all Angular, jQuery, you name it. We're going to get the power of TypeScript talking to those libraries with the syntactic stuff that we get, the benefits that we get from TypeScript. So just as kind of a screenshot here, John Papa has some great Pluralsight courses, and he did one on TypeScript that I really thought was good. And what you have here is, in order to reference that definition, that type definition file, you just have the // this is Visual Studio. You have the / reference, you give it the path, and now this is a knockout implementation, but now you notice as soon as he starts typing stuff, he's getting IntelliSense in Visual Studio for scripted files. That's pretty cool. And he's able, and when he calls methods, you notice here, it's enforcing the types that he's passing as well. Yeah. I've only been working with Visual Studio. Has anyone else had any experience with TypeScript and other IDEs? So yeah, I'm not, yeah. you're referencing the TypeScript file in an older JavaScript. I think it's treated as a comment, right? I've never had experience with that. That's good. Yeah. Yeah. Good question. That's actually one of the points we'll go over. Okay. Back here. So Stuart, who is my plant, actually had the perfect transition into our next topic. Modules versus namespaces. So this is where things get a little fuzzy because pre-TypeScript 1.5, and I've been using 1.7. Right now they're on like version 2.2. We'll talk a little bit about the version 2 features. But basically, before TypeScript 1.5, modules were basically external modules. And namespaces, before TypeScript 1.5, these were called internal modules. So it's kind of confusing. As soon as you get to 1.5 and up, we separate the concepts of modules, which are always external, and namespaces, which we'll talk about in a second here. So the idea behind modules is that we are having code that is importable, exportable. You can kind of think of it as having reusable components that you can swap anywhere in your application. And for larger projects, this is what they recommend to do. They recommend, in order to organize your code, to avoid global namespace conflicts, to modularize things and have reuse, you want to be able to do, you want to do that. You want to do that in your larger projects using modules. Namespaces, which is kind of what, if you've ever worked with namespaces, it's very, I would recommend using namespaces in simpler client-side projects if it's a very small project. Basically, you're just avoiding namespace conflicts with your namespace stuff. There's really nothing else to it. And then you reference your external namespaces with your / syntax that we showed you earlier. So just to kind of illustrate the difference, it's kind of hard because we're doing everything in this kind of environment that's not really portable. But basically what you have, back to my, where'd it go? Did I lose my playground? Shoot. I better spell it out. Okay, here we go. So basically, for example, if we have an interface and dog implements animal type of thing, just your basic stuff here, with this export, we can pick and choose of this file what we want to make available outside of the file. So, and then we can alias it as well. But and you can also selectively import things from other files. And again, since this is just a playground, this isn't actual a setup with a normal application, you would just have the path to the file here. And you can now use those classes or whatever functions, classes, interfaces, whatever is there that's exported, you can import it as well. And you can import all with just the import star stuff there. In terms of if you don't want to do this way and you want to selectively export things here, I like to kind of all do it in one place, but you can just add the export keyword in front of any one of those, whether it be a function, a class, an interface, and you can do it that way instead of having to do it down here. So either way works, but that's basically modules for you. In terms of namespaces, namespaces are a little more straightforward and kind of the same concept, but with namespaces, you're just avoiding conflicts. The idea is I see what you're saying. Thank you. Okay. So basically, and if you're familiar with this concept of wrapping the functions and calling it with the params, immediately invoking it, same concept here in the generated JavaScript. But you can nest your namespaces. You'll just want to make sure that you export the ones that are nested so you can access it. And now you basically just do the dot syntax that you're all familiar with your compiled languages. Yeah, go ahead. Good point. Another plant. We're like almost to that point. You guys are like planning everything out perfect. This is awesome. Okay. Inheritance. Back to Shanaz's question here. Very straightforward. And we'll try to end about 7 or 8 more minutes. In terms of inheritance, it's very easy with the extends keyword, and that's it. You have your inheritance. In terms of constructors, you actually do need super. It is required, even if the base class doesn't have one. That's one kind of nuance of TypeScript. But in terms of extensions, that's pretty much all you have to do, and now you've achieved polymorphism essentially, because if you call the publish method on whatever, you can do that through inheritance, right? It's just going to be, well, yes, that's true. But this is interesting. The extends keyword, obviously we're extending the syntax. So in order to achieve this in JavaScript, I mean, look at all this stuff you have to do. It's crazy. That's one of the ones where you really get the bang for your buck by just doing it all in TypeScript. So we already talked about polymorphism, so we'll skip over that for sake of time. Abstract classes, exactly what it implies and how you would expect it to behave. If you mark a method as abstract, then you have to mark the class as abstract. And basically you have, when you extend things, you can't actually instantiate book. You would get a compiler error. Okay. You still have it here, but in the abstract class, again, the base class, if you really don't need it, it's optional. Okay, static classes, back to your point, or static methods. Again, very straightforward. You have your calculator class. You can mark a method as static, and that means you can't access it with the instance, but you can access it at the class level, right? So if I tried to do instance.add, no, it's not going to work. But if you access it from the class level, you can do it that way. You can mark, in terms of marking the class static, I don't think you can do that. Okay, so you can only do it at the inner levels. Generics. This is, in my opinion, a very useful thing that TypeScript has. If I have a lot of common code that the only thing that's changing is that data type, of course you can use the any, but if you want to be stricter about that with generics, similar syntax to a lot of your other compiled languages, you just have a type T, and you can declare that in your method. You can pass it as a parameter, and your return value could also be that as well. So generics, very straightforward, and that just gets substituted out when you go to call it. So you put in here, you can even have interfaces, classes, primitive types, whatever you want in here is a generic. Which brings me to my next point, which is generic constraints. Generic constraints are quite a bit different than your compiled languages in TypeScript. You can do an extends inside your generic, and that essentially achieves generic constraints. That's the only way you can do it. And then in this logger base, you can say, okay, it has to have this method, it has to implement this interface or whatever. It can even be, it doesn't have to be an interface. But with the extends keyword, similar to kind of what we're doing with inheritance, the same concept applies to generic constraints. Okay? So if you really want to crack down on this, that's the only way to do it that I know of in TypeScript. So we only have a couple more minutes, but I wanted to really quickly go through some Angular 1 examples of using TypeScript and kind of putting all of these concepts together. So we have a very simple form. getting contact info. We have phone number, phone, whatever. Again, I'm going to export this stuff because when I do an API call, I want to be able to, in another file, reference this view model. I'm going to add the export here in the module, and we have, you can think of this as a namespace. We have our class. We have all of our Angular dependencies here. And then in the constructor, we're basically matching up our dependencies here and passing it into the constructor. Now, what's nice about this is you're getting a lot of powerful things in here. So you see, I'm getting IntelliSense here because now we're strongly typing everything. So in my model, in my Angular model, I can grab whatever. And you can get compiler errors too if you have the wrong type. So for example, phone number, I believe I marked it as a string up here. So here, if I try to put it to a number, it literally will not build. So you've got a lot of power in being able to statically check your code now that you're using TypeScript. And now, when we're doing an API call, so this is the way to do a controller. I'm literally just passing in the class to my Angular module, or the controller is a class, essentially, and you're just passing it there. So you get, with just a few keywords and a few syntax things, again, all of this stuff, all of your Angular type definitions and auto IntelliSense, all that's built in because we're extending all of these ng dot whatevers. Now, in terms of an API call, let's go ahead and take a look at how we do that. So we're going to do an actual post. I expose this as a service. And again, the service itself is just going to be a class. So this is these are all my API methods. I have my constructor. And again, we're strongly typing this stuff so that we have the enforcement that we need. And then you literally just call the instance of the class. And you'll notice here what we're returning. If I can find it. Okay, and this one we're not. But you actually can strongly type your Angular promise object. And here, your classic, this is the success function, this is the error function. Again, now I can strongly type what's coming back from the server and enforce that in my client. So if I do something like that, we see success is a Boolean, it's not going to let you do that. So again, very powerful in extending all of your Angular stuff. Now in terms of really quickly, I wanted to show you, yeah, this MVC validator. An example of doing a directive using TypeScript. So here, we have the directive, and this is a little bit different. We want to inject Angular dependencies into our directive. So we're going to call a factory method that's going to do the injection and then return that class, or return the directive as such. So basically, we just have our dependencies here, and we can do directive.inject. Again, all this is valid code because we're strongly typing it to the NGI directive factory. We return that directory. Now we have built our directive with our dependencies, and now inside here, a directive is literally just a class that implements NGI directive, and we have all of this stuff that you're used to seeing in Angular. And I know it's bad, but we're mixing a lot of jQuery in this. But in order to achieve what we needed to do, we needed to use the jQuery unobtrusive validation. And long story short, we decided to expose it through a directive. So now in here, we literally can call in one method, do all of our MVC validation. And then we can pop up, we have a notification service that pops up all the messages at once instead of doing it traditionally field by field. So again, that's just an implementation example of Angular and using TypeScript. This whole process went a lot smoother using TypeScript. Okay, and just really lastly, what's new in TypeScript 2? You can tell that there's a very active community, both contributing to TypeScript because it's open source, and a very active support for TypeScript, because you look at this feature list for Angular 2, and it's, we don't have time to go through any of these, but you've got a lot of features going into TypeScript version 2. Null and undefined aware types, lots of things. So in terms of TypeScript 2.1, which I believe is the latest version, we're now getting into some more advanced concepts like async functions, mapped types, all of this kind of, we actually have support. We can target ES 2017 and do all of this cool stuff as well. So in summary, I hope this has convinced you to use TypeScript instead of raw JavaScript in your applications. We have familiar object-oriented programming concepts. It's much more expressive, much more, I think it's less error-prone, more bug-free as a result. We can scale. We have enterprise-level JavaScript applications that can now scale much easier. And if you're going to use Angular 2, you're going to want to do TypeScript because it's the preferred language of Angular 2. So you're going to have to learn it eventually, right? Open source, it's cross-platform, it's well-supported. The conversion process is easy. Again, it's a superset. So that means you have a raw JavaScript file and you just change the extension to a TS. It's still going to compile and run just fine. It's going to work. So if you only convert 1 or 2 files in your project to TypeScript, great. You can leave the rest as is. You can even rename them to TypeScript and start from there. So in terms of an incremental approach, it's very facilitative of that. Any other questions? Yeah. Certainly going that way. I wouldn't be surprised. I mean, you look at the way Angular 2, the architecture, it's compiled. It's the equivalent of a compiled language in so many respects. It really is, and you need it because front-end stuff is getting so advanced now. You need some discipline to JavaScript. Yeah. Yeah. You know, I haven't read into that, but I definitely. It really depends on how big your project is, the nature of it, but we've had pretty good luck with. I mean, with Visual Studio having built-in support, we don't really do a whole lot of configuration to begin with. Just have exports and imports and our type definitions, and we're good to go. I mean, it doesn't get too unwieldy, in my opinion. Yeah. Yeah, good point.
So then TypeScript's not shipped to the browser, it's JavaScript.
Exactly. But you have the source mapping to be able to define it.
Right. So where in the process does the compilation occur? Right. Yeah. And that's probably going to be different.
It depends on your IDE.
Yeah.
But at the end of the day, it's got to happen before it hits the browser. So it's going to happen in whatever program that has support for TypeScript. That's going to use TypeScript compiler.
In your project, in your Gulp build, you're going to follow the TypeScript compiler.
Absolutely. Gulp is where that, yeah. I haven't used Gulp a whole lot, but I'm assuming, I don't know if any of you guys have used it, that's where it's going to happen. Right? Yeah. Any other questions? All right. Thanks, guys.